Hey, what's up guys? We're going to look at thermistors. Nice, easy, quick topic. So what is a thermistor? It's a thermal resistor. A resistor whose resistance depends upon its temperature. And the symbol for it is shown here. Just one that you just need to learn and remember. It's really important to consider whenever we do a topic, what's the point? So what do we use thermistors for? Basically anywhere where we want to detect changes in temperature. So in temperature sensing circuits, where we have in ovens, for example, you want it to regulate the temperature in air conditioning units. You may have it in a heat sensor in, say, a science lab where we don't want to use a smoke alarm, but we want to detect changes in temperature in the room in case there's a fire going on. So wherever we want to detect and control the temperature, another example in your home is in a thermostat. So on your boiler, in a kettle maybe, any of these places where we need to measure the temperature of something, you're going to use a thermistor. So what's really important is that we consider the effect of temperature upon resistance. And it's really important that thermistors do not act the same as metals. When we increase the temperature of a metal, such as in a filament lamp, the resistance actually increases. And that's because the metal ions gain more kinetic energy and collide with electrons more often. Thermistors are not made out of metal. They're actually made out of material called a semiconductor. And semiconductor means that they've got a medium number density of free electrons. And we use the letter N to represent that. So N is the number density of free electrons. Insulators have a low number density. Conductors such as metals have a high number density. And what happens is when they get hot, N increases. That means we've got more electrons per meter cubed. Therefore, the resistance goes down. When they're cold, the number density of free electrons actually decreases, which means that the resistance increases because there's less electrons available to flow, so we've got a smaller current. And you can see that in this graph here. When you increase the temperature, the resistance is going down. So when T goes up, the resistance decreases. But we need to analyze this in a little bit more detail because we're at A level. So let's separate it into 2 points. So number one, at low temps, as T increases, the resistance decreases at a rapid rate. And you can see that because here at number one, the gradient is very steep. So it's decreasing quickly. It's more sensitive to changes in temperature here, because the same change in temperature will lead to a bigger drop in the resistance. And secondly, if we look at high temperatures, when the temperature increases, the resistance decreases at a lower rate. And that's shown by the gradient being a lot more shallow. It's nowhere near as steep. So the same change in temperature is going to have a smaller effect upon the resistance of our thermistor. We say that the thermistor here is less sensitive. So really, when you're using thermistors, you want to be using them at the lower end of their temperature range that they're designed to be used for. If you wanted to investigate and get these results yourselves, you'd need to use a circuit and an experiment, as we can see here. So what we have is our thermistor, which is here, and it's in a water bath, which we're applying heat to. We're going to heat this water up. We've got a thermometer, and thermometers are always used to measure temperature. We have an ammeter in series, which measures the current. We have a voltmeter in parallel with our thermistor to measure the potential difference across the thermistor, and we have a source of EMF. So all we're going to do in this experiment is we're going to heat the water up, we're going to measure the temperature, and we're going to measure the current and the potential difference. Then we're simply going to use our formula. Resistance is the potential difference divided by the current to record the resistance. So then we plot a graph of temperature versus resistance, and we get the graph that we see here. It's a really simple experiment. You could start with water hot and let the water cool down. You just get your graph going in the opposite direction because you'd be starting at a high temperature and then the water would be cooling to a lower temperature over here. So in summary, thermistor is a thermal resistor. It's a resistor that depends upon the temperature of its surroundings. It's used to detect temperature and temperature changes in ovens, air cons, heat sensors, and thermostats. And what's really important to remember is that it's made out of semiconductor material, which has got a medium number density of free electrons. And when the temperature increases, the number density of those free electrons increases. And because you get more free electrons, the resistance decreases. You're getting more current. So the shape of this graph is crucial. When temperature goes up, resistance goes down, and it's more sensitive at lower temperatures and less sensitive at higher temperatures. And that's it. Thanks for listening. See you all soon.